Thank you, Björn, for this very kind introduction. This is about getting you started with Prometheus. It is covering a lot of things that I wish I knew when I started with Prometheus. The agenda for the next about 45 minutes, installing and configuring. That includes also how to calculate the RAM and the disk space you want to use for Prometheus, how to capture metrics, how it works, how to create dashboards, sending out alerts, watching out for pitfalls. This will be the content of the talk. So I assume that you've been using applications in production for some time now. You've been using different monitoring tools maybe, but not Prometheus, or maybe had made the first steps in a test environment with Prometheus. But even if you're using Prometheus for some time, I hope you'll find some new nuggets in there to help you with some current situations that you're in with Prometheus. Right. So Prometheus. Prometheus is for monitoring. And well, for monitoring, what we want to do is we have applications, we have hosts, we have all our infrastructure that we are running. And well, at some point we want to send out alerts. We want to send out alerts if something is not working as we expect it to work, if something is not working as our users are expecting it to work. And well, whenever there's an infrastructure, we also want to do some dashboards. Right? We want to do trending analysis. We want to dig into data of previous weeks and months and find out what has changed in resource usage or in users using our application. Well, and to solve that, well, at least for today, it's going to be Prometheus. There are other tools around to solve that also, but today it's going to be Prometheus. And well, the Prometheus is an opinionated solution. It's there to do instrumentation, being like collect metrics or provide metrics in the first place, to collect them, put them in a database, then to query this data either for alerts or for dashboards, and also do some minimal trend analysis for this. And well, when Prometheus has been built, people made choices. And choices are that it can do some things very well, and you will not need to put any big effort in there to achieve that. But there are other things that are considered out of scope for Prometheus. And maybe you can remedy that by adding some more tools or putting in some more time and brain of yours. But well, it's been designed for operational monitoring. So it's designed to work well if you want to know that the infrastructure that you're running, the applications you're running, are there up in the way that I want them to be up. And for that, it uses maybe 15 minutes history, a day history, some weeks history for alerting. But it will not cover alert, raw logs and events. It will not do tracing. A lot of other things that you will need to do in order to get good observability of your infrastructure. That's all not covered by Prometheus. It's been set up for, designed for a very, very easy setup. Single nodes, you put a Go binary on it, give it some disk space and RAM and let it run. You will not be able to horizontally scale it from when you just unwrap it and add nothing else to it. No clustering, no multi-tenancy, that's not built into Prometheus. You can do still a highly available setup, or what I will show later, but at least it's designed to be very easy to set up, and because it's so very easy to set up, it will be probably the last thing to fail in your data center, so it can be sending out alerts for you while everything else is down already. When you configure Prometheus, all the configuration will be done through configuration files. So if you want something where you can use your mouse and click some configurations, then probably Prometheus is not for you. Configuration files give you the chance to check these configurations files into a Git repository, to distribute it to different environments, to actually initialize environments out of the box automatically. So I think configuration files are very cool. And as we see in a minute, we are pulling data from lots of processes that are running on different nodes on the infrastructure. So Prometheus is 99% pull and 1% push. At least there are also design decisions behind that. And well, it contains just another NoSQL database. It's a time series database where all the data is being stored in. the good thing is you don't need to install another database. It brings it with it. Some data messaging, all the metrics that you pull from your services, you can filter that, you can rename labels. So there's a lot of magic you can do to the numbers. But mentioning numbers, it's all about numbers for Prometheus. Like the size of RAM being used is measured in bytes, that's a number. But also a service being up or down, it's also a number. It's 0 or 1 to Prometheus. Right. And there's a good talk for Prometheus at the last PromCon 2016. Yeah. The decision for pulling is that you will probably, there could be something like a stampede of the herd. If everybody is sending metrics to Prometheus, it might be overcrowded. And one of the advantages for pull is that it will pull the information from the nodes in a way that, only as fast as it can ingest them. But it can ingest them very fast anyway, but it will not be overcrowded by the node sending data. Also, when you pull the data, the node doesn't need to know about the infrastructure where to push this information, and you can have multiple Prometheus server pulling the data from a single node, from a single instance. So these are just some of the advantages that there are. Right. Technical building blocks. So we had this in the middle, this Prometheus logo. How are we actually setting up Prometheus in the very beginning? Well, we need a host, an environment where we run Prometheus on. We can run it on bare metal if we want to. We can put it in containers. And it needs to have some local storage for its database and some configuration files. And from that, it connects to a service discovery. A service discovery could be Kubernetes, so we can find out where all your containers are running in Kubernetes. It can be Consul if you're running with Consul service discovery, but it can also be a single file. If you have something else of an inventory solution or inventory solution where all your nodes are in there, or your applications are in there, you can export it as a file, put it there as a JSON or YAML file, and Prometheus will read that and learn about your infrastructure from that. Once Prometheus has learned about your infrastructure, while it knows about, for example, a compute node that is running containers, one or more, and then in there are applications. So and Prometheus wants to know what's going on in this compute node, and the first thing Prometheus wants to know about is then node information, about CPU, about disk. And what you need to do, you need to install a node exporter. In other environments, you might call it an agent. But this is a Go binary. You install it there, it opens a port, and Prometheus will connect to the node exporter and pull the metrics from there. Pull the metrics about CPU usage, RAM usage, disk usage, network, you name it. And yeah, if all these nodes, all these metrics together is about like 1,000 metrics for a single node that will be collected. As this node is also running containers, you might want to collect information about containers as well, and you run another binary there, going to be a C-advisor in this case. C-advisor will collect information what Docker containers or other containers are running on this node, how much memory each container is using, how much CPU each container is using. All this information is then being collected again and pulled into Prometheus and Prometheus database. And Prometheus will also connect to the application. It will connect to the application if it's a Java application, to get technical stuff from it, like memory usage of a Java application. But you will probably also instrument your application to get more insights, starting maybe with URLs being called, but then getting also on a more higher level, telling it, okay, how many users actually logged in? How many, if I'm doing a banking application, how many money transfers have been done there? How often did users actually pull their list of transactions? All these metrics are then pulled from the application to Prometheus. And now we have a database that's then quite filled with both infrastructure metrics and also application metrics. And at some point we want to send out alerts. And well, Prometheus sends out these information to an alert manager. This alert manager again has an alerting state that's stored on this machine and also a configuration file. And Yeah, and you have a dashboard host where you run Grafana on, and Grafana being then pulling information from Prometheus and displaying dashboards. Again, Prometheus has a configuration file and a dashboard database. So these are the technical building blocks when you want to set up your own Prometheus infrastructure. And well, when you install it, the good thing is, well, it's written in Go. And Go binaries come for different operating systems. You can run it on Windows, you can run it on Linux, you can run it on BSD variants natively and in a Docker container, but you don't have to. So you have a choice. The one thing it needs, well, is a fast local disk, hopefully an SSD, to store all the metrics as a database, and enough RAM to cache the metrics after it's being pulled, before it writes them to disk, or when you do dashboards analysis to do some caching of the metrics in RAM. So I looked up some calculations here. So if you're collecting some 200,000 metrics per second, that will be about 1 CPU core. That's one of the things I found. There's also a very good memory calculator that you find on the blog of Robust Perception. That tells you 1 million series cost around 2 gigabytes of RAM. And when you scrape them every 15 seconds, and you will need some more additional RAM if you do dashboards. Yeah, so one part of RAM will be allocated by the metrics being collected, and another part of the RAM will be used by caching the metrics and calculating dashboards on top of them. There's also, if you're already running a Prometheus instance and seeing that you're using a lot of RAM for dashboards, there's a component from Comcast. It's called Trickster, and this will actually cache pre-calculated dashboard values before they end up in Grafana, and this might help you to reduce memory usage there. And well, you need also some disk space, and for Prometheus it uses about 1 or 2 bytes per sample on disk for each metric. This is done from the Prometheus docs, and well, with doing some math with retention time, ingestion metrics per second, you can come up with examples like, okay, I have 1,000 exporters with 1,000 metrics each that are pulled every 15 seconds. You get about 66K metrics per second. If I want to have a retention time for 30 days for that, I have something like 240 gigabytes on disk space. So now I've sized my machine. I am configuring Prometheus. Again, as I said, it's a configuration file in YAML format, and I configure something like a scrape interval. I pointed to an alerting rule file, and I can either point it directly to the alert managers, a static configuration, or I can use services configuration to actually discover the alert managers that there are. So if they're dynamically scaling up and down my alert managers, Prometheus can connect to them dynamically. For the targets to scrape, or scrape being equal to collecting metrics from, I can give them in the configuration file, then it will be hard-coded, and I probably need to reload the configuration file, what can be a pain. Or I can use the service discovery like Kubernetes and Consul, or I can use the file-based service discovery that will be generic to any infrastructure that you want to run. There's a web UI. The web UI will give you status information about Prometheus. Let's see, I have one open here. It will give you a status dashboard and build information, what can be currently being scraped. But this is just looking at things and and maybe pulling some metrics, but that's it. You can reload the configuration. If you're used to Linux environments, you can send a SIG hub to reload the configuration file, or you can trigger a special URL if you configured that to reload the configuration. That's also possible. Right. Step 1 finished. You have a running Prometheus. Congratulations. And now, well, let's capture some metrics and see how this metrics format actually works. So Prometheus might be different to other monitoring systems that you know. It connects to one of these exporters and pulls all the metrics in one go. This is how this file looks like. This is just a brief excerpt from that. This tells me, okay, there's a node CPU, that's being the node name. I have a label on this metric saying CPU 0 and mode guessed. And then it tells me, okay, 0 seconds of CPU time spent there since this node has been started. And so it goes on for all the CPUs, all the nodes, for all the network interfaces, everything else. And it stores all that in a database. So it's stored as a multidimensional metric. And, well, the number in the middle, the 576 we've seen on the previous page with all the metrics, with all the labels of the metrics that the exporter has provided, being called labels. And, well, CPU is 1, mode user, and also the actual metric name is put into a pseudo label with 2 underscores. That's something you might come in handy when you're doing queries. And to that, Prometheus will add all the infrastructure service discovery information that is around. So the node doesn't need to know on what data center it runs. It doesn't need to know in what cluster it belongs, on what rack it is. All this information is pulled from service discovery, and this information will be added to the metric when Prometheus pulls it from the node. And this is, again, one of the things with pull-based metrics. The receiver of the metrics will know where these metrics come from in a very distinct way, and will be able to enrich all this information. And you can do math with these metrics. There's a query language called PromQL. As I mentioned earlier, to query this NoSQL database of Prometheus. So NoCPU recalls the number of seconds being used in each mode. So, and this always goes up. It's a counter. It's being reset once the node is being restarted. And you can apply filters to that. You can apply functions to that. And what I've done here, I have first applied a filter to that. So I filtered only the metrics of the node being idle. That is in these curly brackets here. I then applied a function to that being rate. So I don't want to have this increasing counter, but the number of CPU seconds being burned over time in a 5-minute interval. And if I don't want to have this idle time of a CPU, but the percentage being used, I can do a 1 minus to get the inverse of that. So I have the result of that is a number between 0 and 1 and telling me how much of the CPU is actually used. And this is then math with a single node, a single metric. And well, I'm usually not interested in a single core on an instance, right? I'm more interested how a complete instance performs, so I can get the average of CPU core usage on a single instance. But I can aggregate that also on a cluster basis, on a data center, on a rack, to give me a better idea what's currently going on here. With more advanced PromQL, I can do analysis in a way. For example, I have a cluster with 4 nodes, and I can get me alerts if one of the node clusters is using more CPU than all the other cluster nodes, and something is obviously wrong here. The load is not equally distributed, and I should investigate that. So I can compare the averages of different nodes to other averages. Right. And all these metrics come from exporters, and we've seen some on the previous slide already. So we had a new node exporter there collecting host metrics from Linux systems. There's also a WMI exporter to collect metrics from a Windows system. We had seen a C advisor. And well, these first two I installed them once per host. When I want to monitor Java applications, either by adding an exporter to the application itself. So if it's in-house developed, I probably add the Java simple client to that. application. If it's not in-house developed and maybe using JMX to export things, I put a Java agent to each single Java application. So you might see the number of exporters increasing over time. The more of your infrastructure you're actually monitoring. There's something like a MySQL exporter. A MySQL exporter being something you run as a sidecar next to each database. So that is then collecting all the metrics from a MySQL database. There's a Graphite exporter that converts Graphite metrics from maybe legacy or previously instrumental applications to Prometheus kind of style of metrics. There's something like an SNMP exporter where you can query your infrastructure if it's going well or not. But this will usually be a single node, or maybe you have at least 4 paths for the data center, once for each data center. If you're collecting information from services that are either external to you or that don't provide metrics, you will have something like a black box exporter. So this will be like, I would say, Nagios style probing. So is it working, yes or no? Plus more information about response time. Is the TLS certificate still valid? How long is it valid? All these metrics then would come from a black box exporter. And finally, the push gateway. The push gateway that will give you, that will collect information about short-running jobs, maybe jobs that run only 30 seconds, but so that there will be no chance to actually scrape them. They will push the information to a push gateway where Prometheus can collect them. But that's something you would do as a last resort when you can't pull metrics. How you can configure these, if they are specific or not. So usually they are specific to maybe, for example, the MySQL database. And if it's a Java application and it's, the application is already using JMX, then the metrics that are exposed on the application level are already defined by JMX, and it will just transfer these. If you're using a Java simple client, you will need to define the metrics that you want to use as a programmer when programming the application. Like you programmers maybe used drop wizard metrics before, the Coda metrics. And if you're a Java developer, or have Java developers developing application that you need to run, you might want to point them to Micrometer. Micrometer being like the SLF4J for metrics, to collect metrics in the Java virtual machine environment that you can then interrelate with your infrastructure metrics afterwards. So it's a very good fit for Prometheus because you get all this information that we've seen previously in this exporter thing. You get all the labels that you can configure. You can get descriptive help texts that you can define in the API as a programmer that are then exposed in the exporter. It's ready to run with Spring Boot 1 and 2 and also outside the Spring ecosystem. So please give it a try or talk to me afterwards about this. It's also open source. It has a very extensive documentation and it's sponsored by Pivotal, that's the point. Right. So now I have lots of metrics in my database about application, about my infrastructure, being it physical machines, virtual machines, being it databases. And now, well, I want to create some dashboards. And the recommended dashboard solution for Prometheus is Grafana. So who has been using Grafana before? Who has been using it with Prometheus? Some, all right. So for the ones who used Grafana before, it's just adding another data source, Prometheus, to it. So you can query information like you may be querying before from a SQL database or from Elasticsearch, something like this. These are other backends or data sources that you can add to Grafana. And then you can build your dashboards. Well, is maybe a bit of a lie here. You must build your own dashboards. So when you used other monitoring tools like Nagios and Singer or Zabbix, there might have been some out-of-the-box dashboards. For Prometheus, you will build them yourself with Grafana. There are some templates that you can download, but usually it boils down to customizing these templates that then match your use case. The benefit of that is that you can customize them in a way you want them. You can have simple up metrics that show the different up status of different services. You can do CPU usage graphs, you can do disk usage graphs, and you can combine the graphs that you want on a single dashboard, that you make them probably application-centric to show what's relevant for this one application. You can make them use case-centric. Right. Yeah, this is just another graph you can do. Yeah, these are just some of the, you can do tables to show them things. You can show the available memory, whatever. It's most relevant to your use case. You can put on these dashboards, and you can also parameterize them and switch between dashboards. So looking at the time, well, I do have this is one of the most recent versions of Grafana here in the light theme. So that's the light theme I only use for presentations. And you can build dashboards here, and this is then one of the dashboards I shouldn't have switched off my machine at some point. But there's also something that is the people at Grafana added to their UI quite recently, is now the Explore view, something you might want to look into. So you select the data source Prometheus, you go down to the metrics, for example, the CPU usage total seconds, and then you'll be able to dig into graphs here. It also gives you hints, for example, to add a function that we've seen before, like this rate function that you want to apply to a counter to get the number of CPU usage over time. So this is very interactive. You can filter down to different metrics. So this is something, if you don't have that enabled in your current Grafana installation, you probably want to upgrade to the very latest version of Grafana to have this Explore view in there as well. Sending out alerts. So yeah, these things, keeping it up at night. So configuring alerts, that's actually happening in two places. There's a YAML configuration file for Prometheus. So I need to tell Prometheus what kind of metrics to alert on. I give that in another file that's next to the configuration file. In this example, I want to alert when there's a high error rate in my application. So I can put in here any valid PromQL expression. And this PromQL expression is giving me the percentage of, so I first sum up the requests per URI, and then the rate of all HTTP status codes that is not 200, and divide it to the number of total requests. And if that is more than 10%, so if the error rate of one of my URLs being called is higher than 10%, I want to send out an alert. Yeah, and that's probably something that's really user-facing. So, and this is something I want to be alerted at night. And then I can send out this as an alert, put it into alert template with a probably descriptive error message. Right. And this PromQL expression, I can, when I want to change it, when I want to tune it, if I find out I've been probably alerted too often, I can tune this and put it into either a Grafana Explorer view, or I can put it into the, and find out, okay, if I run this expression, how often would I have been alerted in the past? Right? And if I put it not to 10%, but to 5%, how many false alert would there be? So I can use the history that's in my metrics database to find out what's the best value, the best threshold on this error rate. And I can actually write unit tests for alerts. Yeah? I can define some values like this. If these values have been recorded in a time series, I would expect an alert to be triggered at this point in time, and I put all this in a file, check it into my Git repository, and use prom tool, another command line tool, to actually check if the current rule that is in there is still triggering an alert or not. With these samples I put in this test setup file. And I can run this, for example, whenever I push something to the Git repository and have probably a GitLab job or a Jenkins job to roll out this configuration to my production or test environment. It will first test all the tests or run all the tests to find out if any of these fails and if I've broken some of my alerting rules by editing them. Yeah, and again, you should alert for symptoms that are that have a customer-facing impact. Otherwise, you will get lots of alerts and probably alert fatigue. That's one of the good advice from the site Reliability Engineers book they wrote at Google, and only those who require human intervention for that. Configuring Alert Manager, just another YAML file. You define some routes where to send the alerts to. You can define multiple routes, multiple receivers. You can notify by Slack and Telegram and whatever. And the thing is, Alert Manager will bundle alerts, and that's something that might come to a surprise at some points. Yeah, and I'm not showing here the alert templates. That's something you probably need to configure to have proper alert templates for Slack or whatever you're using. The technical building blocks that we have for sending out alerts, it would be a monitoring host. Prometheus, we've seen that before, sends out alerts to Alert Manager. We have lots of built-in alertings like PagerDuty or Slack or several others. So you put in an API key and will be able to send out these notifications. But you can also define a webhook that goes somewhere else. There are extensions you can add, something like Gyro Alert or whatever you pronounce that, Gyro Alert. So whenever an alert triggers, it will open a Gyro ticket or probably reopen an existing ticket, so you have a history when it has been opened the last time. There's also an Alert Manager bot if you want to connect to Telegram, but Telegram is not built into Alert Manager, so you go via another Go binary Alert Manager bot that connects then to Telegram. Right. Watching out for pitfalls. So, while naming conventions. While naming is one of the very hard things in IT. And the good news is there are some naming conventions for Prometheus, and you will find them on the Prometheus homepage. You should have a single application prefix, so know that this comes from Prometheus or your application. You should have a single base unit. You should count everything in seconds and not in hours and minutes. You should count everything in bytes, but not in kilobytes and megabytes. And then have some logical structuring. So probably something like Prometheus notifications total, being the total number of notifications sent out by Prometheus. The process CPU seconds total. So if you follow these naming conventions, you will not need to. You will need to do less relabeling, less reorganizing of your metrics afterwards. And this probe gives also some kind of self-documentary metric names when people then try to reuse your metrics in a Grafana dashboard. There's also often the question what to measure, the use or red or 4 golden signals, whatever. When you hear talks about monitoring, you often come across these. The basic idea behind that is to have some consistency when you define metrics in the first place. So that when you start recording metrics, and then maybe in a month's time you want to add a dashboard and you find out, okay, I'm missing a metric. So you need to go back to the application, add this metric, and then maybe wait another day or two until it's being deployed, collected some first metrics and find out if it's working. So this is something you don't want to be in this situation. So having examples like a database connection pool, you want to measure the maximum number of connections possible and the active number of connections and the errors. When you go to an HTTP endpoint, it's more like a request perspective. You want to measure the request, the errors, and the duration. And let's see how these map to this request-based approach. You would always, for request-based resources, well, that's strange anyway, but request-based things, you would measure the rate and the errors and the duration. If you have something that's resource-based, you would measure utilization, saturation, and errors. Or if you're more of a Google type of person, if you define everything as a service, then you would and go with the Google's 4 golden signals. You will measure latency, traffic, errors, and saturation. Yeah, you have to decide for yourself which one to use, but then only use one of these. Or like the 4 golden signals overlap with the other 2. So make up your mind, try it out in your environment, what works best for you, but then stick to one of these methodologies. Right. Even a database connection pool, you can measure with errors and traffic and latency. Like, think of these as more like a mental checklist. Whenever you add a new resource to the application, something new, you go through this checklist. How would I measure latency for this? How would I measure traffic? How would I measure errors? How would I measure saturation for example, a database pool? Well, all of the slides will be on Twitter after the talk. And they are also in your sets as participants. All right, so something like metrics explosion. So we've seen labels, and these labels you can add them, well, to your metrics as you want. The thing is, it shouldn't be too many different. The cardinality shouldn't be that high. So it's probably a bad idea to put the username as a label to your metric, because then you might have hundreds and thousands of different values of that label, and this will be lots of time for each combination of labels. Prometheus will record one time series in its database, and will also use some bits of memory to keep that in memory. So avoid these high cardinality labels. Too many metrics, they will slow down Prometheus, they will slow you on your dashboards and make it actually unusable, and probably get Prometheus in a state where it's no longer able to send out alerts. To avoid this, there are at least 2 strategies I know. And one is to define a configuration parameter sample limit that will limit the number of metrics being provided by one exporter. And when you look at the videos of the last Prometheus conference, there was a tool called Bomb Squad to defuse such a metric explosion to configure Prometheus at runtime whenever this sees a metric explosion. Then, yeah, so that's a nice tool. I recommend you to watch this talk about Bomb Squad. But until you have Bomb Squad, you probably want to have this metric number limit there in the first place. Some things I often get questions about. Alerting for metrics is always good when there's a metric, but if you want to alert if there's no metric, if the service is gone, if there's no instance up, it gets a bit tricky with PromQL. And these are some excerpts from the Robust Perception blog where they show how to alert on a missing metrics. For example, if job is not running at all, and you can have an unless operator in there that you can put to your PromQL query. Right? Or if you want to alert on no node available, if you have a cluster, and you probably have a very good alert rule if it's usually 4 nodes and then it goes down to 1 node, right? But what happens if no node is available? So you want to have an alert for that as well. And then you have this absent operator that you can apply to that. That trigger when no node is then up and running. High availability, as I said, you will have the idea behind that. You have first one string being the application being scraped by one Prometheus. You have one alert manager sending out information to Slack. And to do this in a high availability setup, you add another Prometheus and another alert manager, and you're then in a highly available setup. So your application is scraped by 2 Prometheus servers. There's 100% self-contained. They don't communicate with each other. And then they send this information to both alert managers. Each Prometheus sends alerts to both alert managers. And the alert managers will take care of deduplicating the alerts and sending out only one alert for each incident happening there. The pros, it's really a shared nothing infrastructure with moderate complexity. The cons is, well, each Prometheus might or probably will have a different view of the infrastructure because it's scraping with some seconds apart. So they are tracking the state a bit differently. So, summary. The good news is Prometheus can ingest lots of metrics and very efficiently. We've seen in the hundreds of thousands of metrics a second that you can ingest and stores them in its own time series database. So you set up a one-go binary and you're ready to go. PromQL gives you a query language that you can do a lot of stuff with one single metric. You can aggregate it, you can get a rate, you can also do some simple regression analysis to find out, okay, the disk is half full, at what point in time it's going to be full. And you can also relate metrics. You can find, for example, how much CPU is being used per user being active in the system when you relate an infrastructure metric to an application metric. Right. And you can do alerts on metrics in a way we've seen, okay, the error rate of a URL that's happening. For example, if it goes up for more than 10% on a single node, I want to be alerted. If it goes up for more than 10% in my whole cluster, I want to be alerted. All this is possible because I have things in a database with metrics, and I can relate infrastructure to application metrics. You can run it natively. You can run it natively on the multiple platforms and inside Docker containers. I also spin up Prometheus regularly on my laptop for development purposes. Sometimes you can also, if you have a test environment, this test environment has running its own Prometheus, but I can run the Prometheus locally, try out the configuration. This local Prometheus is then pulling in metrics directly from the test environment, and I see how this actually turns out for me. So this is very handy. For best results, always use a fast local disk and enough RAM. I got you some formulas and links on the previous slides. There's both a disk, the formula for the disk space calculation was in the slides. And if you follow the blog to robust perception, there's also an online calculator for the RAM usage based on the number of metrics you're scraping. So with that, you're all set for a good performance of Prometheus. It's all about scraping, and as you might have found out by now, at some point in time you will have lots of exporters being running on different nodes, running for each database. We can create a highly available shared nothing setup. What's very good to let you sleep well at nights and only alert you when something is really in trouble. And well, service discovery, that's one of the big pros. Prometheus can find out if new things are added to the infrastructure without a person, well, if a developer decides to scale up an application or adds a new node at some point, nobody in operations will need to reconfigure monitoring because Prometheus will automatically know about this. It's also the same when you add a new metric. This metric will automatically be pulled to Prometheus in the database, and nobody needs to configure something for that. There's a good book about Prometheus written by Brian Brazil, one of the core members of Prometheus team. That's published by O'Reilly. I recommend it, and it's really good. These are the links about some of the things that I talked about today. It also got the robust perception blog on it, my blog post about micrometer, and some posts about Grafana. And Prometheus, the Google SRE book. There's a Chrome plugin for Prometheus, so you can format metrics a bit nicer. And I posted the slides on my Twitter account 45 minutes ago. All right, that's it. Thank you very much.